Boy, do I have a treat for you today. We're going to be unboxing the BIQU Hurakan. The main selling point of this 3D printer is that it comes with Klipper pre-installed. They went with a typical Ender 3 style design to keep costs down, but it's got some nice upgrades on here and it's got Klipper, so let's put this thing together and see how it prints. We've got our frame, we've got our X-axis gantry, and finally we have the base of the 3D printer. Let's just put this thing together as quickly as possible. So let's just slide this on. Shoot, I always put these things together backwards. I've got to unscrew these and flip the whole frame around. Alright, now we've got the top frame the right side around. Oh shoot, now the X-axis is on backwards, so... This is just a reminder that you'll probably want to follow these step-by-step instructions. I love how overbuilt this bracket is. I mean, this is the definition of over-engineering. You can pick up the whole printer by the bracket. I'm going to give one mark against this machine for not including wire clippers. I guess they figured since it comes with Klipper, they don't need to give you even more clippers. Alright, and we've got a bunch of little wires to plug in. I really like this hotend wiring. Just got a tiny little connector with all the pins you need. This just looks a whole lot cleaner, and it makes this whole hotend assembly much smaller. Very cool solution by BIQU. Also, I really like the design of this hotend shroud. It's got a tiny little bed leveling sensor here. This thing is really small. It's about a quarter the size of a standard CR Touch. Then we've got this narrow body with these two blower fans for part cooling. Here's the tiny little hotend fan. There's the breakout board. Everything's nice and if you take a look at the heater block, it's got some nice extra machining done to it. And if you look in there, it looks like this is not an all-metal hotend. If you're just doing PLA and you want to print PLA quickly, then the PTFE lining is okay. I'm not going to say it's great, but it's okay. They actually have a little surface mount LED built in here, so we should get some lighting when we start printing with this thing. The wiring in there is really tight. That's just the downside of having a hotend that's this small and compact. It's a little bit of a pain to work on. Now that assembly is complete, we go to the next step, which is tuning. So they recommend tightening the V-groove wheels all around on the machine. This bed is quite loose, so you're definitely going to have to tighten this up. It's kind of annoying to reach underneath this build surface, so just completely remove the heated bed. Then you've got your V-groove wheels that you need to tension down here. It's just a lot easier to get access to them once the bed is removed. Alright, that's feeling good. I think a lot of printers have the actual bolts that hold down the V-groove wheels. They're too loose. And I want to do a deep dive on how exactly these V-groove wheels work. I was reviewing a machine that had steel wheels, and it was showing some ugly patterns in the prints. And I really got into the details of how these V-groove wheels work. So that'll be a topic for another video. You're going to want to tighten up these nuts a little bit on most 3D printers. And this is something I haven't really done in the past, but it's something I'm going to do from here on out. I think I can get a little bit of grip on this bolt head, enough to start tightening this nut at least. There we go. This nut was pretty loose. And when you tighten those nuts up, that's actually going to stiffen up this bed in the wobble in this direction. Now this is a topic that I really haven't heard any YouTubers talk about, but it's something that's, I think, incredibly important for getting these V-groove wheels tensioned correctly. Alright, let's move on to the next topic, so we'll put this back on. I just finished doing the bed leveling procedure. Basically, it has you do a round of manual bed leveling, and then it does mesh bed leveling and saves the results. So now this should be pretty much perfectly level. The next step that I need to do is set up the Wi-Fi so that I can send prints to this machine wirelessly. And a lot of you may have heard of Octoprint before. This goes many steps over what Octoprint does. You can change a bunch of settings that are normally only editable in firmware through the Klipper web interface. So it's a really powerful tool for modding and changing things around. So to set this up, I guess I just need to turn this off. It does this weird flickering thing when it turns off, which is a little unsettling, but it's probably fine. And then I take out this SD card for the operating system. This is essentially what powers the Raspberry Pi or equivalent. And then I'm going to plug this into my computer and enter my Wi-Fi information on there. This printer takes a little bit longer to boot up because it's having to load an entire Linux operating system. So it just takes a little longer, and this is the screen that you get, and you can't really use it until this menu goes away. Okay, so after that step of just entering those two fields of your Wi-Fi information onto the SD card, you just have to go here and look up your IP address. So you'll just want to go to that IP address that's showing on the screen using any computer that's on your local network. So you press enter, and then that loads up this website, which is your interface. And you can see all this information about your printer. From this interface, I should be able to send print jobs to the 3D printer. Now this is a nice bed surface. I really appreciate how they provided a high quality textured PEI bed, but I have something else here. This is a PEX bed. It came with this steel wool. I really don't like using steel wool on a 3D printer because some of the strands can get loose and that might cause a short on your electronics. The real reason I'm using this PEX build surface is because I want to review the Kingroon KPS-3. So I reached out to Kingroon and I was like, hey, can you guys send me a KPS-3? And they were like, no, how about you review this PEX build surface first? So I was like, okay, sure, I'll review the PEX build surface, I don't care. Kingroon, please send me a KP3S. My first layers are all good. My opinions of this printer so far are quite positive. This thing runs really quietly. The fans only turn on when they need to turn on. Even when it's running the fans, it's not that loud. There's just a lot of things to like about this machine. Who knows, maybe there's a lot of things to like about this Kingroon PEX build surface. Kingroon. So now I think it's time to run the test boat. I want to try setting up resonance compensation using Klipper. I haven't done it before, but it can't be that hard, right? There's a special plug on the back side of the machine, so I just plug this special cable in, and then I plug the other end of the cable into this accelerometer. Uh-oh, kind of felt like I was breaking it when I plugged it in. But we're all good now, so I just need to find a way to attach this. I think I just put it on like that. Yeah, I don't know how to do this. I put it in over here. Oh, it looks like it fits in pretty nicely right here. That's probably it. Okay, this is good. Now I need to press the input shaper button. Okay, here goes one more time. You can see it's moving back and forth. And it slowly increases in speed. It also decreases in amplitude. So as it goes to these higher frequencies, it's not moving back and forth quite so much. So we'll let that run, and then we'll change the setup for the y-axis. I need to attach it to the bed somehow. I've got it kind of pinned down against this bed. And you want to be careful not to cause any shorts here, but I think this is in a pretty good spot. So I'm going to go ahead and repeat that procedure for the y-axis. Wow, it's shaking the whole table. I wonder if that'll influence my results. Probably will. Wow, this axis causes a lot more resonance than the x-axis does. I can hear this low frequency humming, even as low as 50 hertz. It's kind of shaking this frame. This is really interesting. So if you look at the whole frame of the 3D printer, like this whole structure up here, that is, like wobbling back and forth like this. So it could definitely use some cross braces, so just like something that ties this top here down to the bottom to stiffen up the whole structure. So I really like this. I'm learning a lot of things about how these printers work and what kind of resonances occur. All right, I don't want to touch things because it's going to mess with the data. Wow, this has been a really interesting look into all the 3D printer vibrations that occur. So we've got all that data saved to the computer now. This new Benchy is running at 300% speed, so it should finish a whole lot faster than the first one that I printed. But I'm curious what kind of quality I can get at these higher speeds. Alright, I just got that filament to escape the path there, so I can just unload it. Oh crap. This is why I hate filament runout detection sensors. It's just extra crap you don't need. Unless it's a direct drive machine, then filament runout sensors can work pretty well. But on a Bowden setup, it's just a pain in the ass. So here's what I'm gonna do. I'm just gonna take this exit hole or whatever this is and just cut this. Now that that's cut, we can unload the filament. There we go, and it just goes off to the side. That's what we want. Now we've got it all loaded back up and we can resume our print. Okay, so this is in the SD card menu. We go here, SD card, resume printing. Now that this print is almost finished, let's set the other print up next to it, and we'll do a full comparison between these two Benchies. Now these Benchies are printed at about 150% scale, so they're a little bit bigger than a typical Benchy, which is kind of cheating. By making this bigger, you're kind of artificially making the print quality look better. And we can at least compare the non-input shapered Benchy to the input shapered Benchy. So for the input shaper Benchy, which is the one that's finishing up right now, I actually increased the speed to 300%. This first Benchy took over 3 hours, and this one here has taken about 1 hour and 24 minutes. Keep in mind, that's with me fumbling that filament change, so that probably added about 10 minutes. I would have done a blind comparison, but since this one has red on the top, it's pretty obvious that that's the second one that I finished. But let's take a look at the quality here. I'll pop this off the PEX build sheet. Seems like most printers nowadays are shipping with these PEI textured sheets, and they work really well, but having another option is always nice. Sometimes you want a really smooth surface finish on your bottom layer, so this PEX print sheet will be perfect for that. On the left we have our stock Benchy, that printed in a little over 3 hours. And on the right we have our input shapered Benchy, where I cranked the speed up. I'd say overall it looks pretty nice. I'm not noticing any major differences between the two. You can kind of see a pattern on that back wall of the Benchy. This is just because we've got a really reflective situation going on here. If you're just looking at that wall head on, you won't notice it, but if you're looking at a shallow angle, it'll really amplify any inconsistencies in the surface. And if we look at this one, even at shallow angles, the quality looks much higher. So if you really nitpick these, I think the one that was printed slower looks better, but at first glance you can't really tell them apart. If you look at the stringing performance, the faster print actually has less stringing than the slower print. I'm guessing just maybe the temperature was running a little bit lower. That tends to help clean up stringing. Also, if you're pulling that string away really quickly, maybe it helps break the string and keep it from being pulled along for the ride. But yeah, from a macro level, there's really no difference between these two prints. Also, I've started to notice these vertical lines through all of my prints, and I think it's from the wheels. Do you see these vertical lines? I really pointed it out on the Tronxy Crux, but you can see it on this one. I think these vertical lines are caused by the wheels themselves. When I looked at some of the prints that the Voron machines were printing at East Coast RepRap Festival, I noticed that they were super clean prints and they didn't have any kind of surface inconsistencies. And any time it perfectly slices through the whole model along like a single X coordinate or a single Y coordinate, then I have a pretty strong idea that it's caused by the bearings. Because as these wheels roll back and forth, the balls always land in the same spots when you go back and forth and back and forth. But I'm curious what you think about these two prints. Which one do you prefer? Do you want the one that takes forever, or the one that's 3 times faster with only slightly worse quality? 9 times out of 10, I'll pick the faster one. This is the boat that ran at 3 times speed with input shaper. This is the one that ran at normal speed. And it's undeniable, the one that ran at normal speed is nicer. But is it 3 times nicer? I could get 2 or 3 of these Benchies in the time it takes to make one of these. And let's look at that bottom surface from the PEX sheet. It's nice and shiny. Here's our 1 times speed Benchy. Looks pretty good. Here's our 3 times speed Benchy. Also looks pretty good. I did notice when it was printing, the internal support structure was actually nicer on the 1 times Benchy. So that might result in slightly higher strength on these slower parts. So for the utmost performance, you probably still want to go with a slower profile. But, you know, these are both pretty good. Neither of these is perfect in terms of extrusion. Looks like they both under-extruded a little bit, so I do need to do some tuning on this printer. The last thing I noticed here is the slow Benchy has sharper lines, like along the outside of this door. The fast Benchy, everything got smoothed out just a little bit. And if you look at the hull, the fast Benchy looks a little bit less shiny. It's a little less glossy and more matte. That might just have to do with slight differences in the temperature, or maybe the print speed affects that stuff. But in any case, the slower print looks a little bit shinier. Let's take a look at what's on the inside here. I undid these 2 screws to pull out this heat break. It's got some stuff to glue it in place. I think this is a PTFE lined hot end, so I'm going to get a replacement in for that so I can print higher temperature materials. This looks like the same heat break that they use on the BIQU H2. I'll leave a link in the description to where you can pick up a replacement heat break so you can turn this into an all metal hot end. It looks like they've used some kind of glue. It's an interesting choice that I haven't seen on other printers. It appears to be some kind of silicone-based adhesive. But let's take off this nozzle here. It's hard to get a grip on this thing. I've always found the best tools for the job are these Knipex wrench pliers. Then I've got another pair of their Cobra pliers. They work good at holding onto just about anything. They're a little more aggressive though, so they can scratch up whatever you're fastening or unfastening. So we'll just undo that. Just as I suspected, there's some PTFE inside of this heat break. You can see there's that PTFE lining. Not a big fan of that. I wish they would have sent this out with a all-metal heat break. I guess another thing that I'd like to see is a direct drive extruder. Right now they're using a Bowden tube setup. This heatsink is pretty beefy. It looks like it's a little bit heavier than it needs to be. Then we've got our breakout board here. Big Tree Tech B1 hot board up. It's a pretty nice design. Much better than what Creality was able to accomplish. But I think I could make some improvements to it. So I might be reverse engineering this and doing another modder board. I think the last thing that I want to look at on this machine is what's going on in this base platform. So let's open it up. This screw is a little loose, so if you ever get any loose or rattly stuff coming from the bottom of your printer, you might want to just tighten these up. You don't really need to torque them down that much, but at least having them tight enough that they won't rattle loose over time will be a good thing. Alright, so let's see what we got in here. It looks like we have a little fan that's attached to the case. Wow, this is cool. It comes with a little schematic of the board on the inside of this panel. So when you take it off to look at it, you've got all this information here. What this tells me is BIQU as a company really wants you to understand how your machine works and wants you to feel comfortable with modifying it. So we've got the entire pinout of this motherboard here. This is Big Tree Tech's Manta board, and you've got this little add-on board that's attached in up here. And that's basically your Raspberry Pi that's running the Klipper environment. All in all, I'm really impressed with how neat everything is in here. and how everything's integrated into this one main board. Looks like we've got a bunch of power connectors in here. I would like to see crimped ferrule ends on all of these connectors. At least they put crimped ferrules on the main power supply connection, but I'd also like to see them on the heated bed here, which it doesn't look like they've included. But altogether, this is a really impressive setup that they've got for the board and the controller and everything. You've got our 4 stepper drivers here. One of the most common failures on a 3D printer mainboard is the stepper drivers. They're replaceable, so if you burn out one of these stepper drivers, you can just pop it off and put a new one in. A lot of these are just pass-through cables that go to the bottom here, so when you plug things into the back, it's actually plugging it directly into this main board. And that's like your Ethernet cable and USB cables, so you can just plug a webcam in back here. They found a good way to package this power supply, so it's just completely enclosed underneath this cover. They've got a nice big fan opening for this stuff. This is a really well-made design, and I really like what's going on in here. You can really tell that this machine was designed from the ground up to run Klipper. Unlike the offerings from Creality and FLSun, who provide like a secondary board that attaches to the outside of the printer to provide Klipper functionality, this one's got it all built in, which is always going to give you the best and cleanest user experience. I'm not sure what kind of power supply this is. It appears to be unbranded, but you know, it'll probably get the job done. Another nice touch is they've integrated the stepper motor into the frame of the machine. I always like when they do that. It's something that Creality really hasn't figured out how to do. There's stepper motors hanging off the sides of all their machines. It'd be much nicer if they just incorporate it into the base like this. Now, real quick, I'm going to turn the power supply on and see which one of these fans spin up. None of them? This is really cool. That means they've got little fan controllers for all the fans on this machine, and the power supply fan doesn't kick on unnecessarily. So this is a super quiet build, and I always like machines that are quiet when they're at idle. Overall, I'm super impressed with this machine. It's been really fun to work with, and having a Klipper environment that's just pre-set up on the machine is a real selling point. I know Klipper has great documentation, but every time I try to install it and I have to get all this special software and drag and drop files all over the place, it gets really confusing. Whereas on this machine, you just load your Wi-Fi information onto this SD card and you can just access it from any computer on your network. That's super convenient. Also, if you can't figure out how to do the Wi-Fi on this SD card, I'm pretty sure you can just plug this in with an Ethernet cable into your wireless router and just get going immediately. So I'm really impressed with this machine and how easy they've made it to get started with Klipper. I think installing and using Klipper can be intimidating at first, but since the whole setup process is done for you, you just plug this in and then open up the web interface. I think that's a much better starting point to get your feet wet with Klipper. Once you start using all the web features and advanced tuning options that are available in Klipper, I think you won't want to go back to using a Marlin machine. The whole idea that you have to get an SD card, put your model on it, and then plug it into the machine to get it to print is kind of outdated. And what I really like about Klipper compared to other cloud options is that Klipper just runs on your local network, so you're not sending your models out to whoever is running the printer. For example, the Bamboo Lab X1 Carbon and Creality Cloud and some of the other printers that have cloud functionality require you to upload your models to their website. And it's none of my business what you're printing, and it really should be none of their business either. So having a layer of privacy built into your 3D printer I think is important, and I guess SD cards are the best solution if you want everything to be closed off. But the next best thing is having this just on your local Wi-Fi network and not sending things up to some third-party server. Over here we have an all-aluminum extruder. It's a Bowden setup, which I'm not the biggest fan of. But at least it's all aluminum, so you won't have to worry about this thing breaking. A lot of the older Ender 3 machines come with a plastic extruder, and also you've got dual drive gears here, so you should be able to print pretty fast with it. We've also got that filament runout detector over there, which I'm not a big fan of. And if you look on the back side, we've got a single lead screw setup. There's no lead screw on this side. I'm going to be doing some mods to this machine. You know, I can't keep a printer stock for long. So the first thing I'll be replacing is this heat break. Then I might put a direct drive extruder on there. Maybe I'll make a new motherboard for it. But overall, it's a great machine, and I'd highly recommend it if you're looking for a printer to get started with Klipper, but you're a little bit scared of the whole setup process and flashing a Raspberry Pi and all of that stuff. So as always, thanks for watching, and I'll see you in the next video.